Hi all, I am Tejeshwar. I am doing an intern as a junior data analyst training in Me Data. And this is my second video, which is crop recommendation system. Let's move on. Okay, first import the necessary packages. Import Pandas as PD. This import Pandas is used to import the dataset using this PD function. This pd.read.csv. This read.csv is an inbuilt function in this Panda. So we want to import this Panda to use this read_csv function to import our dataset. And this matplotlib and seaborn. These are two main packages for visualization. These are the necessary packages up to now. If you want to do any recommendation system like any models, we want to import the necessary packages afterwards. So first we will continue with this. And just import the import the dataset using the pd.read_csv function, read_csv function, and this is the path of the dataset. Okay, this is my dataset. First, it is just analyze what is this data. Okay, this is the crops. What are the crops are cultivated and this crop year. What are the crops are cultivated in the particular year and the season. At which season the crops are cultivated and at which state the crops are cultivated, and the area of cultivated crops and the total production of the crops and the annual rainfall at the particular state and the particular year when we cultivated these crops, and the total fertilizers used, the total pesticide use, and with these things how much yield we got. That is, this is the basic details of dataset. Next, our another duty is to check any null values. If there is any null values, we can't able to do anything. So we want to see whether there is any null values or not. To check whether there is a null value or not, just use .isNull.sum. And this is the attribute which is used to calculate is there any null values or not. If you use just isNull, it don't add all the null values. So use .sum function to add all the null values present in the dataset. Now I used this, but I don't have any null values, so I am just having output as a 0. That's it. Next, data.describe. It just describe about all the integer format or float format attributes. Okay, first crop year. In this crop attribute, this crop attribute is in categorical variable, so it don't come under the describe function. So it directly goes to crop year, and the season or state also will be not there. Okay, what is the crop year? In this crop year, we have total count. The count is how much rows we have. We have around 19,689 rows. With it be equal in the total things. And mean, what is the mean of the crop year? There are majorly 2009 is the average years. So what is the standard deviation? 6. So it can be around 2003 to 2015 is the standard deviation. So what is the minimum value? 1997. So our data set is starting from 1997 and the 25th quartile, which means 1/4 quartile, right? 1/3 or 1/4. Yeah, it is around 25% of our data 2004, and at 50% it is 2010, and 75% it is 2015, and our upper limit, which is 2020. Our lower limit is 1997 and our upper limit is 2020. And that's it. Okay. Next, add SMS area. Total count is 19,689. Our mean is 1.799 and this same like numbers. These are fully numbers. You can just, this is our basic details. And SMS annual rainfall count, mean, standard deviation, fertilizers, pesticide yield, everything has in this. Okay, next, data.info. And this data.info will give you how much null values are how much non-null values are present, and what are the data types of the columns. That's it. And also the memory usage of the total data set. So I have around 10 columns. It starts from 0, so it seems to be 9. And yeah, I have totally non-null count, which means value will be there is equal to 19,689 values I have for all the columns. And I have this data type crop as an object data type, crop year as int, and season state as object data type, and area as float, in production as int, annual rainfall as float, and it continues. So I have data types as float data types with 5 attributes, integer data types with 2 attributes, and object data type with 3 attributes. And my total memory usage is around 1.5 MB. That's it. Okay. Up to this, our basic analysis finished. These are the things like we want to do to know about our data set. Now, we go to the analysis part. Okay. The analysis part states that first, we are starting from the state. Just we are calculating what are the states are placed higher, which means in this data set I have a lot of details about Karnataka, Andhra, West Bengal, Chhattisgarh. These are the top 4 states in this. Like Karnataka has 1432, Andhra has 1266, West Bengal has 1094, and it continues. These are the top 3 states or majorly participated in cultivating the crops in India. And as same as for crops, in this, the major crop cultivated is rice and maize and grain gram, that's moong dal, and urad dal, that's it will be continuous. Okay, and to calculate these things, we just want to use dot value underscore counts. This dot value underscore counts just count all the values is present for only the crop. How much crop just we have, like we have around this much crops. Okay, and these crops will be count for all the things, how much state or how much crops are cultivated along that. Okay. Yeah, next we are just going to visualization the charts. Okay, this is a pie chart, and I'm just going to see what season is being dominated in this data set. Okay, so I just used this season, and I just used the value counts to just count all the values in this season, and I just used the labels to label this like whole year, winter, summer, autumn, rabi, kharif, and it wants to be unique. Okay, if I didn't put this unique value, it will be like line in this total charts, so it will be around clustering, so we can't able to see anything. So I just used this unique method to show as a neat data set. Okay, so we from this chart we can able to see the whole year crops. That means the crops that can be cultivated the whole year is dominated in this pie chart. Okay, the whole year crops, and next the kharif crops, and next the rabi crop. So this whole year crops is better used in this India. Okay. Next crop area distribution by state. To place this title, we just want to use plt.title. Okay, and also to name this x label and y label. Okay, label which we kept in x-axis and label which we kept in y-axis, this total crop area and state. And so that we want to use this plt.x label and plt.y label. And I just want to group all the state and the area. Okay, to it's at Uttar Pradesh there are a lot of, the Uttar Pradesh is the first state in cultivating crop in the wide area. So to calculate this, I just want to group the state and the area, which means I want to search for some, this is Uttar Pradesh, right? So at Uttar Pradesh, what are all the area is cultivated? I want to group all the things into the Uttar Pradesh, and I just want to add. So I just dot sum. This is used to sum, and I just use sort values ascending equal to false. I don't want to use this sorting methods, so I just leave that. Okay. Yeah. So I just group, and I just added, and I just sorted this things. And now plt.figure. This will help you to show your charts more than the normal size. If this is a normal size, I just put this plt.figure fig size equal to 12, 6. It just quite bigger. Okay, so you can able to see this chart and this chart total distance, sorry, total area. So for to zoom your chart or to zoom out your chart, you just want to use this plt.figure fig size. Okay, next to put the bars, so I just used the plt.bar. This is used to put bar chart. And area by state dot index means this is the area by state I used, and this will be used as x-axis, and the area by state dot values will be used as y-axis. Okay, and this index will be like what is this state names. Okay, and the values will be in the numbers, because our area value is in numbers, right? Yeah, that's it. And X label, Y label, title. And to put these names, Uttar Pradesh, Madhya Pradesh, Maharashtra, these are all you can see it is in slanting wheel. To put that slanting wheel, just use plt.xticks here. Plt.xticks. Xticks means the values which remain in the x-axis. The rotation equal to 75 degree. Rotation equal to 75. This will be in the 75 degree. If you want to put 90 degree, you want to put 45 degree, you can. Okay, next. This is for production and for states. Okay, what are the states produced? What are all the crops? That's it. So let's see first the code. I used this plt.figure to zoom my chart. Next, I used the scatter plot. In this, I have used SNS. SNS means seaborn. I just used the seaborn for scatter plot, and X as a state, Y as a production, hue. This hue plays a major role for coloring the charts. So in this you can see some of them are in orange color, some of them in red color, and some of them in pink, some of them in blue, green, and like that. So to place these things, you just want to use this human method. This hue is like it allocates the colors for all the crops. So you can see here it says let's see, arecanut is in pink color, harhartor is in somewhat light pink, and castor seed is in somewhat orange, coconut is in orange. Like that, it just allocates all the colors for all crops we have. In this you can able to see like Assam is having this green color. So what is in this green color? Let's see, this green is in sweet potato, sugar cane, small minutes is same, something it is here. So it will be like this. So if you want to see this Tamil Nadu, it is in pink color. So I think some around this things or the piece something in this so yeah, it is. For this the hue is used, and data equal to data, which is our variable. Data is a variable, and I also use this xticks for this slanting. Sorry, how for the slanting variables. Okay, let's move on to our visualization. Yeah, I mean this gets over. Yeah, our visualization gets over. Now, for this data set, I can also do this crop recommendation model, crop recommendation system, anything. Okay, to do this crop recommendation system, we just want to convert our categorical variable to numerical variable, because all the models such as decision tree, linear regression, logistic regression, any model in this prediction models, any prediction models is only able to classify or calculate the integer type format. Okay, so we want to convert our categorical variable into numerical variable, so that we want to use this label encoder. Label encoder just convert each and everything into a numerical format. That is, if I use the season, for season we saw here, right? Now we have 3 object variables, so we are going to convert these 3 object data type into a numerical data type. That's it. What are all the 3? Crop and the season and state. So I just crop, season and state, these 3 I want to convert into a numerical format. So I just used the season, state and crop. I just want call the label encoder function as LE, and I'm going to fit. So fit which I'm just going to attach or I am going to transform this into one data type to another data type. Now you can able to see the converted data just here. So you can able to see season. Let's say season only has 5, right? So we have around 5 seasons of whole whole winter, summer, autumn, rabi, kharif. It will be allocated like whole year as a 0, winter as 1, summer as 2, autumn as 3, rabi as 4, kharif as 5. Some around it will be arranged as 0, 1, 2 in numbers. So we can able to see 4, 1, 4 like. And also for crop it will be assigned, and also for another thing state. So also for state it is assigned here. Now I just encoded. Now to create any models, I want to use this train test split, because I want to split my data set into 2, training data set and test data set. If you want, you can also split as a 3, which includes validation data set also. Okay. Now it's enough. This train test it, and we want to import the dysentery regressor. Dysentery has both regressor and dysentery classifier. If you want any one, you also use trend. If you want dysentery regressor, you can use. If you want dysentery classifier, you also can use that. And to get the accuracy or to evaluate the model, I just used mean square error and R2 score. This is not R2 score, or square score. Okay. This is our new data set now, and this is X and Y is known as dependent data and independent data. In this you can able to see X is an independent data on the X-axis. So now just leave this yield, and these things are not dependent, right? Crop and crop year is not dependent. Crop year and season is not dependent, or crop or season is not dependent. Crop or state is not dependent. So except this yield, these all things are just not dependent on anything. But this yield is dependent on pesticide. How much you put pesticide, it can make a lot of yield, or it can decrease your yield. Also same as fertilizers. Also it is dependent on annual rainfall. Also independence on state, because each state has a specific soils. Also independence of season. Also independence on, it's not dependent on year. Also dependent on crop. Okay. So the X variable wants to be independent attributes, and Y wants to be dependent attributes, which we are going to predict. Okay, so now this model is going to predict the yield with this data set. If I just provide it the name crop, the crop name and crop year and season, state, area, production, annual rainfall, fertilizer, pesticides, if I provide all these details, it just tell me how much I can able to yield in that crop or in that season. So that's the power of Y. Now I just want to split that data set into 2, train and test. So I just used X train and X test, Y train and Y test. This is used to X variable for training, X variable for test, Y variable for training, Y variable for test. And I just use train test split function with this X and Y attributes, and I just keep my test size at 0.2. This test size is 0.2 is not finalists. This is not finalists. You can able to change at any time. This test size equal to 0.2 means I just used 0.8 as a training data set and 0.2 as a test data set, which means I used my entire data set in 18% of data set as a training data set, and in my entire data set I used 20% as a data set as a test data set. And this random set is a function which is used to randomize our data values, which is means equal to 42. Okay, now model equal to, I just call in my model dysentery regressor as a model. I just allocated a variable for model, and now this model dot fit. I'm just going to train my model. To train a model, we want to use just fit. This fit is used to train the model. X train and Y train, I am just going to train with the training data set. Now after training, I just going to predict. After what? Oh, just a minute. It's just reloaded. Yeah. After training, I am just going to predict with the test variables to check the accuracy. That's it. Okay. It's to check the accuracy. I just calculated the model dot predict with the test variable, and it's printed as some numbers. We can't able to understand this. Only missing, and I need to understand. And I'm just going to calculate the mean square error for this model and R2 score. Okay. In these two things we have just calculated, and the next is to print the mean square error and the R2 score. Like mean square error is around 1111939. Around it is high, and R square. This R square provides your model's accuracy. The R square's most accuracy is 1. 0 to 1 is the R square value. If it is nearby 0, your model is low accurate, and if your R square score is if your R square is nearer 1, your model is better predictable. So we have around 86, so 0.86, which means we have around 86%. So we can say our model is around 86% perfectly fitted. Yeah, and these things are on the, yeah, that's it. Okay, thank you.